I'm going to go ahead and screencast the simulation for those of you that are working on an iPad. If you are working on a computer, you probably have access to Flash, so you can just go to the link that I gave you for the simulation. However, if you're working on an iPad, you might not be able to run the simulation on there. So you will definitely have to pause this video as I go through the simulation to record your observations and then restart it. But this should give you enough information to be able to complete the lab handout that you have. Just give me a second. I will share my screen with you. Okay, so if you go to the simulation, you open with a page like this. In the next exercise, you'll be able to test several metals with different aqueous solutions. For example, you can place zinc metal in a copper nitrate solution, and you're going to be able to make some observations about what happens there. These here are the different solutions that you'll be looking at throughout the lab. We're going to go to activity 1. I'm going to start by choosing magnesium metal, and I get strips of magnesium metal. And when I hit click here to place the metals in solution, they'll be lowered down into the solution. I'll remove them, and you can pause the video here and write down the observations that you made about the magnesium in each of those solutions. Next, I will choose copper. I'm going to do the same thing. Lower them into those 4 solutions. Remove them. You can pause here and make observations about what happened to the copper in each of those solutions. I'll choose zinc. Place the zinc in each of those solutions. Pause and make some observations on your lab. And finally, I will choose silver and place it in each of those solutions. Remove it. You can pause and complete table 1 from your lab. Next, I'm going to go to activity 2. This is the same idea, but we have some different solutions and different metals here. You're going to be recording your observations for activity 2 in data table 2. So I will start with pieces of iron metal. Lower those into the solutions. Make some observations. Lead. Lower those into the solutions. Make some observations. By the way, in this simulation, these colors of like the iron nitrate and the nickel 2 nitrate are pretty accurate to what they would look like if we were doing this in a lab. Choose nickel, lower that into the solutions, and remove it. Pause here and make some observations for that. And then last for activity 2, I'll do the same thing with tin, SN. Make those observations. We'll go to activity 3, same idea, different sets of metals and solutions. Start with iron. Copper. Next, we'll go to zinc. And lastly, we will do lead. You You can pause here and finish up any observations you need for data table 3. Next, I'm going to go to activity 4. This one is slightly different. In this case, I have a beaker of hydrochloric acid, and I have 5 of the other metals, the metals that we've tested already. And one by one, I'm going to lower those into the hydrochloric acid and make observations of what happens. Again, pause your video to take observations as time goes along. So we'll start out with a strip of silver metal, lower that into the HCl. Hit remove and remove the silver. Next, I will go with copper, lower that into the HCl, see if anything happens. I can remove it when the simulation tells me to. Nickel, I'll lower that into the HCl, make some observations. And remove the nickel. Lead. And finally, a strip of tin. And I will remove that. And that is all of the steps of the simulation. So you can go back and rewatch that or pause it where you need to make observations. I went through that pretty quickly. If you were actually doing the clicking and maneuvering yourself, it would probably take you a bit more time, but you'd also have more time to make those observations. So feel free to rewind, rewatch parts of it, pause it where you need to. But that should give you all the information that you need to fill in those data tables in the data results section, and then use that information to answer the questions at the end of the lab.